Okay. Audio sounds pretty good. So I guess we'll get back into it. Hopefully, wasn't abandoned for too long by my friends. So what were we doing? Okay. I want a theme to keep track of all the different quads. The rectangle, the bounding rectangle. So I think what that means is I need to distinguish between world space and local space. Set quad corners. Local. Got to think about this for a second. I mean, once again, muddying the waters a little bit by adding more function calls. So if we set the quad corners in quote unquote world space or in parent space, we have to do things one way. But local has to do with rotations. Okay, let's do this. Before we set these rectangles, const rectangle and reference are pretty sure rectangle has an assignment operator. Yes, equals underscore text quads dot rectangle. Text quads is at 0, whatever. Let's not overthink it. At this rectangle, which is r dot x, r dot y, r dot width, r dot height. Then after we get the new rectangle and we log those textures. Quads rectangle. And what we'll see is we're not really doing anything with that. Whatever the default is for a fine it's just the default. Whoa, 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 whoa. What did I change? Ugh. Set quad corners. Okay. I think we know what to do here. TexQuadBatch. Set quad corners. We do flip the Y there. These are inverted. Aha. Here it is. Those are inverted elsewhere. Still an issue. Okay, so we go to button, or we're actually using the color quad. Upper left, upper left, upper low. Oh no. Okay. Outer rectangle. Inner rectangle. It has to be -2 bevels. Okay, but set rectangle. Set rectangle. Inner. width minus 2 double the bevel, height minus double the bevel. So x1 y1 set quad rapid. Set quad rapid. There we go. The y gets flipped up above. That should fix it, I think. Okay, but the buttons look better. Obviously, still some issues here. Oh. Yeah, 0, 0, 100, 100. So that's just the default rectangle. Nothing changed, which is something we need to fix. Hmm. I'll go figure out what's going on in sandbox here. We broke something that didn't used to be broke. Git diff, I just want the TexQuadBatch changes. Set color, set quad texture. A lot of changes in here. Don't need those. Don't need that. Got a rectangle. We don't need the quad offset anymore. Is that true? Oh. All right. I don't want to be in a broken state while we're trying to update line transforms. Nope, that's not what I want. Mostly back, but not. That is all red. That is multiplied by magenta. Positions are right. Oh. We made everything magenta in the first place, so here, boom, set all the colors to white. Ooh, not error colors. Nobody wants that magenta. Unless it's an error. Right, back to sandbox. Ah, shoot. Okay. We refactor everything to make it simpler, but of course there's always a problem when you refactor. Always miss a line or two of something. Okay, sandbox. Okay, now nothing is showing up except the first one. Which means what? Compute our new coordinates. Set quad corners. Vertices for quad. Those textures should be getting set. Okay. Less. Well, that's. Zero width height. Over, down, over, up. Hmm. 0, 1, 2, 3. Y0, Y1, Y2, Y3. Those are all negative, which is what I'd expect. Huh. Odd index. Texture slot. Underscore vertex textures. Sub text slot name. Not sure what's going on here. Okay. Whoa. It is setting those a lot of times. Um, Possibly because of that. Not inside the for loop. Okay. What did I break? ColorQuadBatch. Assert our quad index is correct. R.x, R.y. And these look identical. Set quad index x0, y0, x1, y0, x1, y1, x0, y1. So those are the same. Let's add a couple more. Let's add a couple more functions for testing. Well, text offset. X2, Y2, X3, Y3. That all looks correct to me. So what am I doing wrong? Okay, assert xy quad vert honestly these look identical. Is there something wrong in my render function? For each slot bind samplers, sure. Oh, great. Okay. Possibility 1. Why don't we pre-invert all of the y values? Just see what that does. Okay, so that doesn't help at all. Not sending these doesn't make a difference. Why would it not render the other one? TexQuadBatch.cpp. Okay. Where are we setting up our indices? Right here. Oh, okay. All right. Well, that's a problem. Let me do this. We're gonna get 2 different quad offsets times indices per quad. There we go. 1 for indices, 1 for the other thing. Low efforts. He's back. Yes, I'm back. Glad you could rejoin. We found out when we refactored those other batch rectangle things that we broke something else. So we're just putting it back together. Then we'll get back on track. One of the fun things about programming, you're spend 99% of your day with nothing working. Not if I'm gonna run it. Color quads are looking okay. Oh, sort of okay. There are some issues there. Okay, those are back on track. Color quads still not quite right. Color quad dot. Oh, I know why. I know why. I made a change just a second ago, which is wrong. It's your bevel times 2. Oh, not color quad. ColorQuadBatch. But that's not it. Here we are. This is what I changed, and that's not right. We just fix it. Then the buttons will look right. I'm doing a game engine the long way. Writing image loader for bitmaps. Lol. C89. Oh, 89. My goodness. So, image loader. What image formats are you supporting for bitmaps? Okay, bitmaps aren't too bad. Bitmaps are reasonable. I've written bitmap writers before. It's the inverse of what your problem is, but yeah, if it was PNG, I'd be very impressed. PNG is a complicated, including it has to try multiple different compression techniques and pick the best one. So that all works. Those buttons look better. Okay, so we're back where we should have been. Git status, git add, git commit, refactored, batch renderers, batch renderers to do things. Net PBM. Seems fairly trivial. Okay. I'm embedding the raw binary data for each image. So you get a width, a height, and then 32-bit colors array. I'm just embedding the whole thing as binary data into my executable. And we are going to compress that towards the end of this project. And I think we're going to do it with QOI. Have you heard of it? QOI image format. I think it's this one. Let me put it in the thing. It gets compression similar to PNG, not quite as good, but the load time is considerably smaller because it's a much more simple. So basically, you're trading off not quite the best compression, but understanding and parsing it is so much easier. You have a plain text header, then either plain text data or byte. Yeah, that one's trivial, but oof. The text overheads. The text overheads. We just wrote a config file that we save and load, which is 40 bytes plus a set of characters at the end instead of key value pairs. We're embedding binary data. And yeah, that 50 bytes, 40 bytes plus some text makes me very happy. Because then I think about how much room it would take me to store the keyword and the value and how much more complicated the parser will be. It's beautiful. There are reasons to have text-based data, but I think it's overused. To we set for text data in certain paths, code paths. This is in support of the affine updating itself. All right, so TexQuadBatch. So, oh, my children, set quad corners. Okay, so this is not quite right. We are setting a local coordinate, but we are not updating affine's rectangle. So affine keeps track of basically our, let's see here, raw rectangle and our transformed rectangle. So when you ask for the rectangle, where is it? There's a function for this. This one is the transformed rectangle. So it has the offset applied to it and the scale, but not the rotation, just for sizing and positional information. The raw rectangle is always 0, 0, and a width and a height. So what we want to do is keep track of these, but we have to tell it about the points we contain. This may not strictly be necessary, but I've interrupted my stream, so I'm trying to take a smaller task than embedding UV data in our image warehouse. So we set the quad corners. If we have a point cloud, let's see here. So let's go back to our scratch buffer. We were just looking at this. This has a position. So this will always be 0, 0. This will always be width, height of the bounding rectangle. So this, no matter what we put in, will be 0 something, right? 0 height and the width. Width 0. This point will be something and height This will always be 0 and some y coordinate. These 3 points in this case define our bounding rectangle. And whatever we put in, we need to transform all the points into this rectangle. That way when we render and we say, hey, move to 0, 0, it's this bounding rectangle point that we measure from. If we had a center offset to it, like if we say the center is here, it's still 0, 0 here, but the transforms occur relative to this center point. It's like a rotation, or actually it might be here, which would be at width over 2, height over 2. That is not 2. If you want a center rotation. So when I add a new set of points, do you use GLM or your own math? So mostly we use GLM for the render side, but we're not using it for everything. Like I'm not using vec2 to store points or things like that. So the GLM is mostly going to be our transformation matrix, and mostly just that. So in our second game, after this one's done and published, we are going to eliminate GLM from our dependencies. That's one of my goals in the second game. Just write what I need. When I need it. So this one we're using GLM, but we're using so little of it. It's a heavy dependency given how little we use it. Okay. So I have to think if everything is like that, we have an affine transform XY. Oh, and scale. No, not scale. We can work with the raw rectangle for this. Okay, we may be overthinking this. What we're gonna do? We're gonna take each of these points and subtract the affine XY. The x equals raw rectangle dot x y minus x. So if our affine has an offset of, if we're putting a point in at 15 and our affine transform is at 10, then we'll be drawing at local space 5. So that looks right to me. Minus dy f3. Search for x. Oh, search for equals x minus dx. Search for equals minus y minus dy. Nope. No, nope. All right, whatever. Minus dx minus dy. We're basically doing this the brute force method for now. Dx minus dy. Then fix affine rectangle. I'm mostly doing a pet project, so I'm going to write my own too. Nice. I mean, honestly, none of it's hard as far as like the math goes. So writing your own, it has less burden brought in with it. Are we a big team? We are myself, and that's it. There's nobody else on here. I'm a solo developer. That's why the art looks like crap. That is the crappy programmer art version, and we will in the next couple of weeks, 2 or 3 weeks, we're going to upgrade to the mediocre programmer art. Maybe I'll commission some towards the end, but yeah, they have a lot of optimization magic in there. But again, I'm not hardly using any of it. Like my use is just the transform. Applying transforms is not rocket science. I don't know how much you can even optimize it. Yeah, as long as you lay out your memory in the same way and pass it on to OpenGL, that's where most of your optimizations are going to come from. So single array, I think it's column major, blah blah blah. But yeah, I'm really not using the math library that heavily in this project. Okay, so for int q index equals 0, q index less than quad index, or m underscore quad count plus q index. First thing we're going to do is compute our quad offset. Or our q offset, our q index. Then for each vertex, v index less than 4 plus v index int v offset equals v index times entries per vertex. Where can you see the game? Twitter isn't trivially accessible for me. I only use Twitter to announce my streams. So the game looks something like this. Let's just see where we end up with a build. Yeah, so the game is simple. And I did that on purpose. As a first game, you start small, right? Limit your scope. M underscore quad count. Oh, num quads. Okay. So and, I can give you a perfect example. Why in Amazon Game Studio. Oh, you see it? You found me on YouTube. Yep, cool. So Twitch will store the videos for 14 days. So you can see all the way back to when I started 4.5, almost 5 weeks ago, and see how far we've come in, 4.5, 5 weeks. But yeah, Amazon Game Studio is like, we're going to create a brand new game studio. We don't have a culture. We don't have any releases under our belt. We're going to hire a bunch of people, and we're going to put out a giant World of Warcraft MMO killer, right? And where are they now? Who's talking about it? What happened to it? If your first project is too ambitious, you make mistakes, you burn out, it causes issues. If you start small, like if you look at Blizzard, they started off with like some little tiny 2D games, not even Warcraft 1, right? It started off even simpler than that. It was like dwarf mining thing. And you build up some tools and you build up some skill and some culture. Then you make game 2, and then you make game 3. Maybe that one is Warcraft 1, which did okay. But by then you've got it figured out. You've made it 2 or 3 times. Warcraft 2 comes out. That was the big one. That was where they turned over, right? And then StarCraft, of course, was a huge hit. It just went on from there until they became large and corporate. But when you do your first project, you start something small. So that's what I'm doing. Small game, easily scoped, and just building up my tools, building up my skills. The second game will be slightly more ambitious. I'll basically fix all the things about this one I don't like that that I put up with but didn't like. Yeah, so here's the game right now. 3 different modes. So it's like a race. As soon as you start typing, the timer starts. You have to guess 6 words in that time. And then we know things about that. Nothing else we can get here. Let's go with BD. BAY. We know. Oh, interesting. We don't know anything. Flogs. Jacks. Waxed. Okay, well, it can't be J or K. Or no, it can't be B or Y, because if it was B or Y, it would also have to be W or X, because the A would be out, right? So that would be too many letters. I've already got 4 of the letters I know, and B and Y would be in addition to that. So I'd also have to add a WX, which would leave me with 6 characters. So it has to be A, and WX are out, and B and Y are out. No T, no S, LI are in, FG is out, RH, no P, U is in, no C, no JK. All right. So we could go with like quail. That's a likely hit, I would say. Boom. So yeah, when we started 5 weeks ago, no animations, no sounds. The game was playable, technically. No art. Like literally, it was a black screen with just the letters on it. So yeah, we've come a long ways in 5 weeks. I like the solo developer experience. I spent enough time on big corporate. Not big. Well, yeah, I've spent some time on big corporate stuff, and I just don't like that environment. I can't get anything done. This way, I make all my own decisions. It's lovely. But back to what we were doing. TexQuadBatch. Okay, so we're gonna go through each vertex of each quad, and we're gonna get the minimum X, the maximum X. So we need double min X, max X, min Y, max Y. If I thought about it, I could probably not do this in the worst way possible. But we are going. Oh, wait, I've just about got it. Thinking through the problem. I don't think I have to. Okay. I'll bet I can compute our required change. Let's go with. Oh, okay, let's do it the brute force way first. I know what I'm doing, but let's just start simple here. It's going to equal underscore vertices plus, well, the quad offset is 0. Vertex offset is 0. So it's going to be an X. Double max X is going to equal min X when we start. Double min Y, which equal m underscore vertices sub Y. Double max Y equals min Y. Okay, now double X equals double Y equals the same thing, but Y. If X is less than min X equals X. I don't actually like that. We'll swap these and turn it around. Min X is greater than X. There we go. If max X is less than X, that Same thing, but for y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. Activision's still on game 2. Yeah. or Steam. I mean, what happened to Steam? They put out a couple of games and they were good games. Portal and... Alright. So we blow through every single quad. We find out what our bounding rectangle is going to be. Rect R. It's going to be at min x, min y. Oh. Negate. Ink. And then max x minus min x max y minus min y. New rectangle. Only finished a Game of Life a couple of years ago, and then I got sidetracked all the time from bigger projects. Yep. It's hard to complete a big project. I mean, this one is pretty small. Right now I'm at, what? Well, I haven't measured. I wrote it down a week ago, and we're going to check it today in about 45 minutes. We're going to check my weekly productivity on this project. Friday is variety day, so tomorrow's probably compiler's day. But each week I do an analysis of how many lines of code I've got. So at the end of streaming week 4, we're at about 15,000 lines of actual code. Never mind the data. It's only a 15,000 line program, right? We'll check that number today. So small project, easy to manage, easy to scope. Valve has no motivation making games for their profit frame, but yep. They can afford, well, and actually their development team is really small. It's actually shocking. Did you get into Emacs for org? No, I got into org because of Emacs. I've been using Emacs since, when? Gosh, maybe 2005? Are you an Emacs person, or you know org mode? So I assume you're not one of those filthy Vim users, or even worse, VS Code. Okay, so we're going to make a new dxdy, which is a float. Wait, that one. Okay, dx is going to be our new rectangle's x. From our raw rectangle. Let's see. Yeah, raw rectangles x minus r dot x dy equals the same thing but for y's. Now we have to go through every single vertex. I used to use Vim, yeah. Use Emacs, but not for org. Got into Lisp, so naturally, yep. Modern C by King, and then I'll finish SICP after that. So, if you want C, honestly, K and R is old-fashioned, but a classic. It's pretty good coverage of just about everything C related. SICP, classic, excellent work. Kind of changes the way you think about programming. Good stuff. In fact, I really like the lectures that are posted on YouTube for SICP. So good choice of books. I approve. Okay, Brian. Stupid error in tic-tac-toe. What is it? Oh, can I link a clip? You can link it. I don't know if I'll show it on stream. I may visit it. We don't need to imagine the hypothetics states. Yep. You just create a new board with a new move in it and evaluate it. Yeah, you can link a clip. We'll take a look one way or another, whether on stream or not. Okay. So if my new rectangle is left of the old rectangle, its x would be smaller. Our new rectangle, we want to move an old point to the new point. So our old x, I need to flip these. It's new rectangle minus old rectangle. And we can add the delta. Yeah, no need to show. Okay, files, cat box. MP4. Want to create a new board doing a thing like, I don't know. Okay. Pixel art with a mouse. Oh, we've got a game of life situation going on. Or something game of life like. Cool. Nice. Did you build that yourself there, low effort Z's? Yeah, that's safe to show. We can show that. Let's see, where's my... You forgot the overpopulation rule. Yeah. Okay. Brian, your board representation. You are using right now a double two-dimensional array, which means each board state can be empty or occupied by a black space or a white space, right? So, yep, int. Oh my gosh, okay. So you're using a lot of space. If you don't want to blow up your stack, you can compress your board a lot by having your board represented as two integers. Where you imagine that each bit in the first integer represents either empty or a black space, and in the other one you have either empty or a white space. Using bit shifting and ors and ands. And then your entire board state can be stored in two integers, which can be ordered together for is a space occupied testing. Does that make sense? Yep, triangle is warp. Okay, first of all, we're going to try to trick OBS into letting me show this video because it's cool and yeah, not inappropriate at all. So I'm not stupid. I've not been caught yet by somebody posting a video and then the game of life. Boom. And yep, overpopulation does not kill anything off. So pretty cool. That's kind of a fun symmetrical. Yeah, very nice. Super cool. So thanks for sharing. Always fun to see other people's projects. And sometimes the mistakes make it look even more cool, I think. Cellular automaton. Yeah, patterns are cool. Well, and that's part of the fun, right? So with a game of life, you can just change the rules a little bit. Yeah, so in English, it's cellular automata. Automata. Yep. In English, it's very close. So have you seen Noita? That whole thing is basically um, a pixel simulator that's kind of like the game of life, but each material interacts differently. Like there's some cool YouTube videos about how to make your own pixel simulator like Noita. It's kind of a cool one. Okay, so let's talk. Ryan, we're gonna help you out here. This we're gonna erase. We don't need it. You have int board xy. I forget, it's like 6x7 or something. That equals something like this: 0, 2, 3, 4, 5, 6, 7. 4, 5, 6. Something like that. And then you're saying that x's are -1 and, oh, that's not a legal move. X's are -1 and O's are +1, right? Yeah, Noita is what. So I've bought it, and I'm waiting for a time when I can like sit down and thoroughly enjoy the misery. Like that's half the game is just watching yourself blow up over and over again, and I just don't have the time to enjoy it the way it should be. Yes, simulate fire, smoke, water. These cellular automata are pretty cool. Okay, so this is what you're using. What I would do is I might do something like this. Uint, we need 42 spaces, right? 64, so we need a 64-bit integer. And we're going to call that white. And we're going to call this black. We're just going to make it 0. Okay? Then each, and what this means is, what's that in comment? 0B, 64, 0. Oh, come on. Beta 64. It's not going to do it? Oh, come on. 1, 2, 3, 4. 8, 16. 1, 2, 3. Okay. So this is our initial state. All spaces are empty for both black and white. Then if you want to like set row, well, then you use bit shifts to explore the first 42 of these. You know how bit shift, bit masking works? 6, 7. Sure, 6, 7. It doesn't matter too much. Have you seen Rain World? No, but it has the crazy involved ecology systems, right? I mean, I've seen it, but I haven't played it. I guess I should say it that way. It looks pretty cool. Feeling like in an game analysis by the retro game mechanics explained. Yes. Yes. I like those simulation systems where plants grow and die, and that would be cool. That's not within scope of my current project. Okay. So if you do like set, I forget. Let's see. Let's just do a test. Bool is black. Cat int column, int row. Bool is white. Same thing. Bool is occupied. Int call, int row. Okay, so if you want to ask if something is black, you take the blackboard. I really like bitboards. They're so compact. Return black, and whether or not it and 0x1, this is going to be bit shifted row times 7, I think. And again, maybe my math is wrong here. Plus column. Boom. Same thing for white. And then here's the fun. Return is white or black bit set. Procedural animation for the characters. I was just watching a video on some procedural animations. It looks cool. There are so many cool projects that you just need to build up to. Noting in my study list, bit operations. Yes, bit operations can pack an awful lot of data. So now, if you want to create a copy of your board, like board, and I'm doing this in a C style. I know that you use Java sometimes. Literally just here's your white, here's your black. So what we've done is we've packed all of the data for the whole board into 128 bits instead of 6 times 7, which is 42. 42 times an integer, which is usually 4 bytes, is times 42, 4 bytes. 168 bytes. Instead, this is packed into 128 bits. Trying's the best. Yes, it is. Try new things. So actually, you'll find that this bitboard method is used a lot by, not a lot, but it's used by some of the old chess engines, maybe newer ones, I don't know. I haven't looked into it. But they'll have a bitboard for white, a bitboard for black. They'll have a bitboard for pawns. So if you want to know where a white pawn is, you and the white board and the pawns board, the bitmap together, and whatever's left is the white pawns, right? Yeah, so bitwise logic, always pretty cool. I think it's pretty cool. So in this case, where if you do start building up your board this way, like start by just initializing the 0 and then try to try to set the board to some known state, like where you say somebody's played here and here, and try to get the board to print, right? Then you'll kind of know did set white and did set black work. Then when you add play black in column whatever, you'll have to test each of the rows down until it finds an empty one, or up, I guess. So that'll be another iteration. Once you can place pieces, board evaluation becomes a simple matter of just more bitwise operations. Very efficient. Okay. So this gets my new rectangle. All of the vertices are going to be relative to a new xy. Find I can set a fine size. I can set a fine red. There we are. Set define rect. There we go. All right, let's try that. Try to make it work and then enhance it. Yep. One little step at a time. First, draw the board. Second, place items in the board. Third, test for win conditions. Yep. May Y is not a real thing. Obviously. But even in the modern world, like setting up a two-dimensional array, it's not going to be anywhere as efficient as integers. So you'll be able to do more layers of depth in your minimax search because you won't use up as much memory. Each board is now 128 bits. Well, that's not quite what we were hoping for. Texture quads is way off. So we clearly have some work to do. Nuts. Okay. Okay, it's time for my restroom break. I will be back in like 3 minutes. Okay. So actually, one cool thing is that you can test for win conditions against black or white very easily. So if you do something like, not very easily, like they have to think about it. To win, you have to have 4 in a row. So what you do is you know that 4 looks like this. 0 binary is whatever number of zeros, right? And then 1, 2, 3, 4. Okay, so what we do is we say horizontal win even 30, that's 54. T H win equals 0x f F means all 4 bytes are set, right? And all the zeros don't matter. Okay? Then, if white and horizontal win equals horizontal win, then you found a win. So you can do like bool is win for white equals false. I'm trying to remember. I did this once ages and ages ago. Well, do something. Else each win bit shifts 1. So what you've done now is instead of looking at 0x00 or 0 binary 1 2 3 4 1 2 1 2 3 4, you've just bit shifted it, so now it's 0b000 1 1 1 1 0. So now you're checking the next set of 4. Are these all the same on the whiteboard? Are all these 4 bits set on the whiteboard? Then you bit shift again, and you bit shift 3 times. Okay? So you've checked 4 values on that row. When you hit the end of the row, the next row looks like this. You take hwin equals 0x0f, and then you bit shift it 7 up to the next row. And then you do the same thing. If white and hwin equals hwin, then you got 4 in a row. Otherwise, you bit shift down that row. So that's horizontal win, maybe a vertical win. I'd have to look up the pattern, but basically it's 1 ORed with 1 bit shift 7, ORed with 1, ORed with 1 bit shift 14, ORed with 1 bit shift 21. And now that's your vertical win to start with. And you have to move that across each of the 7 columns. Again, just all you have to do is next column over is vwin is equal to vwin bit shifted by 1 to move it to the next column. When you hit the bottom of the end of the column, you reset to this, and then bit shift by 7 more bits in order to move up one space and sweep it again. Okay? So if you set up your bit patterns correctly, you can test for win conditions very fast with just bit manipulation operations instead of array index lookups. Okay, back to what we're doing. Okay, sorry about that. More local fire updates. Wow, it's getting crazy around here. I really like this method anyways. Which one? Okay. So we're going back to the way we were doing it. I feel like this shouldn't be so hard. Not that it's hard, it's just I probably needed to draw a picture.
Bro, my dad was always watching Family Feud, so I sat down and watched it.
Let's see.
Steve Hart. Great.
For each of our new points.
Bro, we should play Strike. We should play.
We know our X and our Y. Our rectangles X and Y.
For a while until we get bored and then we can hire occasionally we'll want to get a
So if X 0 is less than oh no, not my raw rectangle. We know what our affine transform is, so affine X is equal to rect dot X Y. Okay. Let's just get our rectangle. Are there any issues with Emacs on Windows? Nope, not really. It seems to work fine. There are a couple of operations that seem pretty slow. Long macros over large files can take some time, which kind of boggles my mind because it should be really fast, in my mind. It should execute all the operations and then re-render, but for some reason it seems to just take forever sometimes.
There's been a lot of
Okay, if we are left of AX on any of these points, oh no.
just LGBTQ simulator started at the beginning of the game. Very cheaply. your own place. Everybody's accepting.
Min x, max x, min y, max y. For each quad, for each vertex, we get the x and y. If it's less than, if it's greater than, it's less than, greater than.
Yeah, it's your play it.
I have to flip the y because I like to work in world coordinates. So that part, I feel like, is fine. Oh, wait. I want to set the raw rectangle and then update the transform rectangle. Okay, so let's go to that. I think we need that ability. Find void set raw rectangle. No, that's not quite right either, is it? No, it has to be the set of fine rectangle. Oh, m dirty equals m dirty or true. There was a place in the code where I was doing, let's see here. So what was happening was I was saying m dirty equals like x equals y. And what would happen is if you did several dirty checks in a row, like if width equals height, it doesn't matter. If x is 0, y is 0, you have some code in between here or whatever. What would happen is sometimes this one would set to true, and then this one would come overwrite it. So if you instead do m dirty equals m dirty or your condition, then it doesn't get overwritten. Your old dirty doesn't get overwritten by your new one. That makes sense? So it's just a pattern I started adapting. Yep. Now, I've copy pasted that same thing into other places in the code, so it's kind of working its way through. But yes, yep. So that's it. That's why it's there in that way. So yeah, in a lot of places, in a lot of places I am using that. It doesn't need to be that way anymore. I honestly think this offset added back in is fine. I think that's fine. Then we look for our min max x and y. I think that's fine. Then we set our new rectangle. We'll start at min x, min y, and then go out to the width and the height. Set that rectangle. But now, the raw rectangle, I think we need to do it this way. Basically, there's an additional offset before we can apply the rectangle. Then we apply that offset to our vertex buffer. We'll see if that works. Dx. All right. Huh. I don't feel like that's super close, but I feel like it's closer than it was. Hmm. So basically, this vertex is being put in relative to the affine position. Oh, here we are. Minus ax. That will help. And then I want to make sure that the y's aren't being flipped. I want this done today. We might go a little long today. Okay, that is actually close. Oh, okay. Hey. So the question is, does that look the same as x equals 0, 8y equals 0? Just for testing, see if those look the same. Those do look about the same. Good. So if we delete that, apply the new rectangle, we're going to see if the affine rectangle looks like it makes sense. So it prints out some stuff. X, y is negative. It should not be negative. In fact, our quads start at 10, not 15. I would expect all of them to be relative to 10, 10, and go down to 390, so 3, 4, 415 in width and height. 10 and 415. Those are what I would expect. 430. 15 minus 165. So that's still not quite right. But honestly, pretty close. Oh, oh. That's a minus. There we go. That might help. If min y is greater than y, equals what? Max y, max y. Super close. Feel like we're super close. $15.10, and instead of 415, we're at 405. Did I math that correctly? Okay, the y is finally correct. This, I don't know what it's doing. This 15, okay. So when we first start up TexQuadBatch, basically what it's saying is zero, 0, 100. Then we move over 110, so that's 110, 110. So we have 410s. Well, no, we have 100 plus 310s. So 330, 430. 430 is the width. The height should be 100. Yep, so 430 and 100. I agree with those. Y is 0. I'm not sure why this x is 15. Why would x be 15? This one, though, should be 10, 10. Then, I guess we need sandbox to look at. The last quad is at 390 plus 225 x and y, which should be 415. But the other rectangles. No. I agree with myself. They should have a fine rectangle of 10, 10. Oh, minus 10. So it would be 405. So width and height are perfect. Y is perfect. X is off by 5 consistently. It should be this 10. TexQuadBatch. And it's drawing in the correct place, so we know that's fine. We get our find XY. We offset everything. Is that not 10? The min X should be 10. We're so close. There are 16 vertices here. Oh. Do you use VC or Maggot? I don't use either right now. I tried integrating with, I think it was Maggot a while ago, and there were things it couldn't do conveniently, so I basically just run it out of my bash shell. I I have on my list a lot of things to do with my Emacs. I need to go through rebuild my .emacs. There's a lot of junk in there from old years. I need to integrate with Maggot. I probably should do something with Mabel. I probably should not copy paste all of the packages around. Ivy versus Helm. Yeah, I've got a lot of things I should do about my Emacs, but I've been pretty static for the last few years about it. So our X coordinate is not coming in correctly. Oh, whoa. That should not be the case. Min X. Width, height, and Y are all working. Here's the question of why. Why isn't the min X? That should be like the easiest part of this. So that's definitely wrong. The width and height are right. Width and height are correct. X and Y are way off. X, Y. You just flip it here. Doesn't change anything. So, what about you? What's your favorite, VC or Maggot? I need to know which one to actually pursue when I get around to that. Maybe I'll do that all on stream. Literally. That's not 0. That is not 10. setting quad modulus d quad index. Oh. Minimum x negative 40. When I minus 50. Underscore. Raw rectangle. See, this starts with default rectangle of 0, 0, whatever. How is min x negative 50? Oh dear. One other thing I have to add to the rectangle, a fine rectangle. Let's just have a note for now. I should take into account the transformed. Will take into account center. Let's put that under technical debt. Our to-do list. Okay.
Was Troy already evacuated? No. That's what Lily said.
Okay.
No, Lily doesn't know anything about that. It's just... Troy's not evacuated. The area around her fire is what evacuated, not Troy. It's out in the middle of cornfield.
AXAY.
Go, I gotta get Ethan to work. His feet hurt, so he's not gonna be able to run down the hill.
I'm missing something. What am I missing? That one doesn't even make sense. Oh, wait a second. Wait just a second. No. Oh, a fan of Citizen, so I mostly try to use out of the box style for Emacs. I'm getting used to VC, but apparently they're looking to bundle Maggot as well. So I don't really need to collab with people who haven't had complicated scenarios. So I'm going to go with CXVV. Yep. The only packages I still have installed are Meow, Velia, Flycheck, and Undo Foo. Wow. That is, okay. Good to know. I will write myself a couple of notes about what you wrote there. Let's see here. VC, Maggot. Yep. Those are common things I've heard of before. Meow. I don't use Meow. Again, I set all this up ages ago and I got kind of lazy about keeping up to date. Yeah. Belay. Fly check, I know. Undo foo is one I haven't heard of or haven't pursued. Okay. Cool, cool. Indenting on save. Okay. That's kind of cool. I mean, I really like the cleanup end of lines on save. That's one I've got enabled by default. Width and height are correct. Y has been correct, but now it's definitely not correct. Why is it off by 1? Did I change any of these rectangles? No. I am missing something simple. If my rectangle says it's at 0, 0, and I add a thing at 10 and wider, this will be 10 minus 0. 110 minus 0, 10 minus 0, 110 minus 0, something like that. Then when I come through here, I start with 10 for min and max. The first point will get 10, which is not going to require to set. The next one will be 110, which will require these to be set. Well, this one to be set. My min x, it better be 10. Oh, or 0, or whatever my first x is. Indenting on save. That does sound nice. I know the vertices are ending up in the right place. Basically, I'm trying to transform x0 from whatever space into our local space. You do that by subtracting the transform, which causes displacement. Yeah, so to probably make more sense if I just did that. No branching. That's probably the pattern I should switch to here, but my top priority right now, min x. Quad index, vertex index, or vertex index are 0, so it's just x and y. Why is it reporting such stupid numbers then? Set ax, ay. New origin. Min X, min Y. Setting quad 0. Our new origin is 29. Where's that coming from? Because TexQuadBatch set quad rect equal to 0, 0, 100, 100. I know where. Oh, shit. Okay. So none of these first ones count. This is the only one that counts. Because while I may have set quad 0, the rest of them are full of junk. So it's entirely possible the quad 1, 2, or 3 before we set it has a X value that's something. Ugh. So until we've set all quads, so this is a junk value. And this is probably a junk value. By the time we get here, by the time we've got to here, oops. Okay. So our fine offset is probably junk, but when we hit the new, which means we're adding and subtracting junk. Erg. So how about this then? TexQuadBatch. We're going to add a little something something here. Textures are fine. That'll work shockingly well. And underscore vertex buffer size. Where's my num quads? Vertices. Okay. Cool. M underscore quad set. TexQuadBatch. I guess we'll make that a pointer as well. M underscore vertices equals that. Equals new Boolean of number of quads. Delete. m_quad set quad index equals false. Quad set at quad index equals true. So for each quad, if quad set at q index, and then we can take it into account. And we can only apply these changes again here. Which also means in the render can be a mess. Render if not defined and debug. Zero q index less than m_num quads plus q index. If m_quad set at q index quad note. Let's put some pens around here. Oops. TexQuadBatch. Oh. Assert. We just assert. There we go. We can't render until you've set all the quads. That's a rule I'm going to set. Can you get unset quads? I can now. Boom. Now 00405 0 10 0. How did that get set to 0? Quad 2. I believe set it starting with 0. That's fine. Our new origin should be 10. So our affine offset is 10. Our new origin is 0 at the end of quad 1. Instead of keeping this 10-10. Okay, all right. One last thing, I think. I think we're very close now. TexQuadBatch. Okay. This has to take into account the current offset. So if we're at 0, and our new one is 10, it moves to 10. AX, AY. I think that's it. See ya. Thanks for coming. Sandbox 1010 405 405. Perfect. Now we can put that rectangle back in. We can set quad rectangle, quad index r dot x plus equals r dot w plus 10. We should now see all the numbers just the way we want them. We're creating artificial offsets and whatnot relative to junk. Sandbox. Okay. 0, 0, 430, 10. Perfect. 10, 10, 405, 405. Done. Now we can do that to color quads. Let's go to TexQuadBatch. We need the set of, did you set the quads? Okay. Very nice. Then in here, quad set. You basically copy all of, let's see, we gotta do a couple things. We gotta copy that over here. Minus 8x minus 8y minus 8x minus 8y minus 8x minus 8y minus 8x minus 8y. Then we set quad equals true. We do all of this. Maybe we leave that in there for, well, we can take it out. Okay, I think this puts the end to it here. Okay. Um, okay. In theory, these all have correct rectangles. Whoa, okay. That is not right. Why is that not right? What? These all look right. These are all color quads. That looks fine. About, settings. All this looks fine. Except where's my quit button? Where'd it go?
That's right. I'll eat one.
So that's a no off. That doesn't do anything. Okay. So what happened to my button? And why is it only in sandbox? Every button used the color quad. If I broke it, it would be broken for everybody. Oh, there it is. That looks fine. Okay, interesting. Okay, it works. Interesting. Okay, one last thing. ColorQuadBatch. In our initialization, we are not going to initialize anything like that. And same with our TexQuadBatch. It's a lot of unnecessary rights when I want to force people to set up their stuff before it renders. Make it clean, make it work. And then we'll do a quick rundown of our code progress this week. Okay. All right. In our journal. Where are we at? Okay, that was harder than it should have been. Updated text quad batch and no, I'm gonna use this shorthand to update their bounding rectangle. Okay. Not bad. Okay. So X quad batch and color quad batch now update their bounding rectangle. Okay, journal. Let's look at how many lines of code we've got. Source, word count, dash line, startup, HTTP startup, CPP, all together. It's a bunch. I don't really care about that. Now what I care about is star warehouse bug. HPP star warehouse dot. There we go. Netcode is this minus this.
Julia is being evacuated right now. They're at stage 3. The whole city.
Okay.
Heads up.
Okay. So netlines added is what we go last week. Which was here, netcode. $800 lines of code this week. A little on the slow side. We've had several interruptions. I'm on project. I will know that after I finish the stream. I'll look at my video timestamps. Lines per hour will be calculated. Release FPS and FPS size. Release size. Okay. So go back in the shell. Pile. Clean. We need a release build. Release. So that'll take a minute. So yeah, the town 3 miles over is getting the evacuation, so we probably ought to be ready to get going if we have to. Three miles is not very far. I should remove sandbox code from that total as well. But no, I really should. I should. Warehouse and sandbox. Gen or test data or test code. Just now this number. Note. Remove sandbox code from line count. Okay, so this is actually coming a little lower than we want. Well, what? Not much? Yikes. We actually wrote quite a lot of code for our testing.
Uh-oh. I was getting a
Oh my gosh. That's like 500 lines of code that we just removed. Minus 507 block. Okay. This week does not look very productive yet. Release. Source build release. Size. So we're up a megabyte of data. We did add an image. Did we add? Okay. And lastly, release frames per second. We go into play. $15, $16, $17. $17-ish. $18, $17, $18. Stony. I'd say we're probably around 17. We're seeing it bump to 18 and down to 16, so. Call that around 1700 frames per second. We'll do the test size calculation later. And that should do it for the week. Tomorrow is variety day. We will do compilers. And I think that's it for me. So thanks for coming. Give a follow. Hop into our Discord or whatever. And we'll catch you tomorrow. Bye.